So my name is Doyle Detro, Enterprise Account Executive with Verisoft Design. We are a Microsoft ISV developing vertical solutions for the Microsoft ecosystem, selling our solutions around the world through partners, through strategic partners. And obviously Optimus is a very important partner for us. So we're going to talk about the Asset Guardian today, our asset maintenance application. We're going to talk about maintenance in the airport context and how we can utilize technology to help improve asset management at airports. So we're going to talk about sort of the challenges of operating in airports. And then we're going to talk about how we help solve some of those challenges with technology to help maintenance at airports. So as you can see here, we've got airports have many challenges. Aging infrastructure, stringent safety regulations, seasonal variations, high traffic volume. Obviously, airports are expanding. You've got security concerns with airports, very complex systems, budget constraints. Many airports are obviously not privately held. These are public operating entities for the most part. And obviously they have to deal with government and the budget constraints that come from government. And as everyone in the world is dealing with today, obviously labor is an issue. So airports are under a lot of pressure to be safe, maintain assets, to get the most efficiency out of the investments that are made at airports. And so technology is a way to address a lot of these challenges. So benefits of maintenance systems, enterprise asset management systems for airports. Airports today are using systems. Obviously, they have systems in place, but many of them are very old, are not taking advantage of the latest technology. So what we are trying to do at Verisoft Design is to help airports around the world, give them better technology to upgrade those old systems, to become more efficient. So we're talking about improving maintenance planning and scheduling. And so what we're trying to do there is we're talking about being better at planning maintenance and, solving problems before breakdowns happen. So not letting equipment fail, not letting things go wrong in the terminals, baggage equipment, equipment that's used to move luggage around in the terminal facilities themselves. So we're talking about developing maintenance plans that allow them to be proactive and plan maintenance in advance to keep things running all the time. And we're also talking about predictive maintenance, so real-time monitoring of assets so that when certain conditions happen, action can be taken to fix something before it breaks down. So we're also talking about enhancing the life cycle of assets. So we want to have data in place that that helps extend the life of assets. So we know that, for example, a certain asset has an expected life of 20 years. We know that there's certain conditions have to be met to keep the asset running optimally over the lifetime of that asset. We want to be monitoring that asset and being able to predict the end of its life but also we want to be able to extend the life of assets. So taking care of them so they last longer than they would normally be expected to last. Obviously, with airports, you've got compliance with safety regulations. You're dealing with local, state, federal, province safety regulations, and the system can help with those safety regulations. And then also, the data is very important. So as we operate the system, we obviously want to be able to consolidate all of that data and present it to decision makers in a very useful way. So the system is intended to do that as well. So talking specifically about improving maintenance planning and scheduling, how do CMMS and EAM systems optimize maintenance schedules to prevent downtime on airport assets, and talking about the efficient allocation of maintenance resources. So for example, in a CMMS system, and this is just a page of something that we call a maintenance policy, but it's assigning a maintenance, we're talking about assigning a maintenance policy to an asset and setting up a schedule so that maintenance can be performed on specific intervals, or it can be based on a meter. So for example, we could set up something to be performed on an annual basis. So once a year, a complete, for example, an overhaul of a certain asset needs to be done. It needs to be taken apart. Everything needs to be cleaned, and it needs to be put back together again. Examples of more frequent activities would be, obviously, like for example, changing oil and air filters on a piece of like baggage equipment. So maybe setting up a policy to say that every 1 month we're going to perform some routine maintenance on the specific asset. We can also do maintenance policies based on meters. So that would be knowing the sort of like the runtime of a piece of equipment. So knowing that the engine on this piece of equipment is running 24 hours a day, but we're actually capturing that information. So having something to monitor that. And we like to do this in real time as much as possible. So being able to actually connect to equipment to monitor how much it's actually used. And as you know, that airports run for the most part 24 hours a day. We can also do maintenance based on both. So you could set up a maintenance policy to say that I'm going to run an inspection on this piece of equipment every 2 weeks, or if it's run, let's say, for example, 300 hours. So whichever comes first. When a maintenance policy is triggered, obviously that queues up a work order to be performed. A maintenance planner or maintenance manager would then sort of approve and dispatch that work order. So this gets into additional tools that are available, talking about maintenance for airports. Here's a picture in our system of a dispatch screen. So we're seeing a list of work orders that need to be performed, and we can assign resources to those work orders. And you can do it visually. So we're talking drag and drop planning of maintenance. Airports have tens, if not hundreds, of people working and performing maintenance on the facility on a daily basis. Scheduling is a challenge, and it requires a tremendous amount of time. There are tools available, and our system has a tool to do automatic scheduling. So on the right-hand side, you can see here we have a tool to assign suggest automatic schedules for maintenance. So a maintenance manager would come in the morning, run their preventative maintenance routine that would trigger all of the work orders that need to be performed, for example, for that day or for that week. And then they would run this tool that would automatically dispatch work orders to everyone working at the airport. It's a configurable algorithm that looks at the skills of certain people It looks at the type of work that needs to be performed on a piece of equipment on that work order. It looks at the priority of that. So it's going to prioritize more critical situations. And you can generate a schedule and it will automatically suggest that schedule. A maintenance planner can then review it, drag and drop work orders around, and then finalize that schedule. That schedule is then automatically sent to everyone working at the airport. So a technician working on his mobile app will then have his schedule for the day, know where he needs to be, the work that he needs to complete for the day. This the ability to automatically generate a maintenance schedule is a game changer for large scale maintenance operations like you'll see at an airport. It's one thing to have people running out and performing maintenance, but actually scheduling people and keeping and assigning the right people at the right time. Airports have very large teams, multiple planners working on this stuff night and day. And with our technology, we look to just make that we're trying to make that a very easy process for airports. Okay, now we'll talk about enhancing the life of assets at airports. So maximizing the lifespan of assets, reducing the cost of maintaining them. One thing our system does is we have something called a health index. So it's a configurable algorithm that takes into account multiple factors, and you can decide how you want to value those factors. So some examples would be the expected life of an asset, the expected cost of maintaining that asset, for example. And then in our system will monitor that. It'll look at the life of an asset. It'll look at how much work is being done on the asset. It'll look at the condition of the asset. You can monitor condition on equipment. So let's say the width of a certain piece of equipment of a component inside of an engine, for example, that's being worn down, and when it gets beyond a certain point, that part needs to be replaced. What we do is allow airports to set up these algorithms to get an overall picture of the health of their assets, and then you can drill down and see this by different types of assets. And it essentially provides a score that you can then use to understand sort of the status of things at your airport. And that can help with budgeting and planning. So I know that if I'm looking at my runways and my facilities and their status, the score is a 75 and we're in good condition, then we probably don't have any major work to do for the next, for example, 2 to 3 years. But we know we're just going to be performing routine maintenance. If I've got a score of poor or very poor, then we know now we're talking about either needing to replace assets, or we can expect that we're going to have higher maintenance costs to maintain these assets that are in poor or very poor condition. This is extremely useful for decision makers to be able to present data to their the key stakeholders at an airport. They're in charge of budgeting and planning for that airport to know how much money they're going to need to operate the airport into the near future. So now we're talking about some of the technology around real-time tracking and monitoring. So this is being able to automatically track the status of assets, or allowing our people to have all the tools at their fingertips to work on assets, but also inspect them and report on the condition of them. So some tools that we provide specific to that problem is, number one, IoT. We take advantage of Microsoft technology. We've integrated, for example, in our case, our system to the IoT lab on Microsoft Azure. So it allows us to deploy sensors on equipment or facilities to monitor, for example, things like temperature. That data is fed back into Azure, and all of that data is collected in Azure and stored in Azure, and we have it forever, so we can always have access to the data that we're collecting automatically from equipment. But we can also set up alerts in Azure so that when something goes outside our expected parameter, we can trigger alerts that then send that data into our CMMS system to trigger, for example, a work order. So we might be monitoring, it can be used to monitor, actual moving equipment, but it can be used also to monitor static equipment in the terminals, for example. You could deploy a sensor for example, on a baggage, for the luggage equipment, and we know that inside that engine, that temperature always needs to be between, for example, 70 and 90 degrees. When it's beyond 90 degrees, we want to trigger an alert to have someone go and work on that equipment. So it's giving you the ability to go take action and fix something before we know it's going to break down based on the condition of equipment. Here's a picture of our mobile app. So this is an app that runs on a phone. It works on iOS or Android, and it's for our technicians. It allows them to see all of the equipment that they need to work on. It allows them to see all of the work orders that they have scheduled for the day. And then it gives them all of the information they need to complete the work order. So it'll have all of the procedures they need to carry out. And there could be, let's say, 10 to 15 steps to complete a work order. That's all in the mobile app. And it's also fully integrated to their phone. So the ability to take a picture and have that automatically saved to the work order. They can also bring up sort of attachments and PDF documents. So if we've got an instruction manual pertaining to the asset, that's all visible on the mobile app. And then it also gives us we've also have inspection form capability associated with the mobile app, and I'll show a screenshot of that. But as someone is filling out and completing a work order or filling out an inspection form pertaining to an asset, that data is captured in real time. It's connected in real time to the database. So we're getting all of our feedback that we need constantly in real time. We're not waiting until the end of the day to have people come back to the office and put a pile of paper on a table to say, this is all the work I performed. These are the notes I took. We're getting all of our feedback in real time. So we're knowing, number one, is the work actually being done? But number two, we're getting valuable feedback on the work that is being done. And also, in some cases, a work order could create another work order. So as someone is performing a preventative maintenance routine, they find a problem, they can then automatically create another work order with a high criticality that may require someone else to come out and help them. And that is all being done in real time. The other valuable component to the mobile app is it does work offline. So if someone's on a phone and they're disconnected momentarily from the internet, or even for an extended period of time, the mobile app is synchronizing data to the technician's phone. They're going to have all of the asset information and work orders they need that they have planned for a day synchronized to their phone. So if they are, for any reason, disconnected from their local area network or from the telephone network, which is a problem at airports, just for the sheer number of people that are at airports, it puts a lot of stress on phone networks. It doesn't prevent technicians from performing their work. As soon as it's detected that there is internet, then all of the data is immediately synchronized back to the master database. This is just a picture of our asset card in our web portal. Here you can see, for example, and this is another way that we deploy our maintenance. So I just showed you the mobile app. This is a web application optimized for tablets. So this is, you can see this page is in the shape of a tablet. And just showing an example of an asset, information that's available on an asset. And as you can see, we've got pictures that can be attached. All of these screens that are deployed, whether it's the web application for tablets or it's a mobile phone app, it's all configurable, so, and customizable at the click of a button. So you can set up a profile based on what certain people need, and they only see the fields that they need to see. They only see the information that's most critical to them. Okay, now talking about compliance and safety for airports, as you can imagine, that's a major issue. Maintenance is critical, obviously, to government regulations, but so in our system, what we do is we have a tool for if we have regulations that require specific forms to be filled out and stored and kept and maintained. We have a tool that you can take a PDF of a form, drag and drop it into our software, and it will automatically detect all of the fields and data that needs to be filled out on a form and turn that into a digital document. So what you're looking at here is not actually a PDF. It's a rendering of a digital document in our system. So this can be brought up in the mobile app. It can be brought up directly on the internet in our web application, but it allows someone to fill out a specific form, and then you could date, obviously, and put a digital signature on that form. That form is stored as an attachment to the work order, to the related work order, to the asset. It can be printed as a PDF at any time, just as if that form were filled out on paper. But what is really, really valuable is, since it's a digital form, we're able to take data from that form and feed it back into our system. So for example, you can see in this form, we've got, we're capturing data related to the terminal. And in this case, item number 1.2 on the digital form is marked as incomplete. That can be fed back into the system to then trigger, for example, another work order, or it can be, we might be capturing the condition of something. And so it can go back into our condition monitoring algorithm that says this certain piece of data was outside of a parameter, which can also trigger work that needs to be performed. But then also we're capturing this data, which is obviously also very valuable for reporting. Okay. Okay, I think last topic, just talking about data-driven decision making. Obviously, reporting is critical. So, it's one of the key components of our system, is being able to provide data to decision makers. Here we have just a picture, kind of a dashboard. This is in Power BI. Our system, we deliver Power BI dashboards as a standard part of our software. So in this case, we're looking at, for example, equipment that's currently out of service. We're looking at our distribution of maintenance activities. So we want to know how much preventative maintenance we're carrying out versus how much corrective maintenance we're doing. So as you can see in this example, 64% of the maintenance that we're performing is corrective maintenance. So that's unplanned maintenance from equipment and assets breaking down. What we want to be able to do is reduce that number. And the goal would be 0%. And that is by improving our overall, maintenance operations so that we completely prevent breakdowns from happening due to the poor quality of maintaining assets. Accidents obviously are going to happen, but we want to absolutely prevent failures, asset failures in airports that are just strictly due to assets becoming old or being poorly maintained. Obviously, this, with reporting, we can capture the cost of our maintenance activities. We can look at it by equipment type, and we can drill down specifically to specific assets. So I know that if I've got snow removal equipment, I've got sort of maybe 10 major pieces of that, and I've got one that just seems to cost, we're routinely performing more maintenance on that one specific piece of equipment compared to the others. We know we have a problem with a specific asset. So in that case, we are maybe looking at returning that to the manufacturer or replacing it altogether. So just, talking about implementing CMMS systems with airports, much like any major business software application, it starts off with doing a needs assessment of the airport, finding out what software systems they have in place currently, what are their major, which software systems need to be replaced, how much of the actual processes at the airport that need to be addressed. And you can see here, obviously selecting the right systems, data migration, training, the ability to customize software to address specific processes. Integrating with existing systems is critical. So we're not just operating in a standalone world where our system is not going to talk to other systems. We have APIs in our software. We're expecting to connect to other systems. So the overall finance system up at an airport, a lot of modern equipment has its own software that comes with it. So some modern equipment will be capturing its own conditions and reporting that back to some cloud system. And in our case, we want to connect to all those pieces of those other pieces of software. Having the right implementation team in place, rolling out a pilot at an airport. So we might just roll it out for example, one department within the airport until everything is working, and then rolling it out to the entire airport. And then obviously, as we spoke about before, reporting, continually improving the software, and reporting is critical. In our case, our software is built on the Microsoft business application, Business Central. So we take advantage of everything that Microsoft puts into Business Central. So for example, security, procurement capability, and just workflows that Microsoft provides. Because we're leveraging that existing Microsoft capability, it allows us to just focus solely on the functional aspects of maintenance, while we get the financial power of Microsoft. It's constantly improving the software architecture, updating the software. Business Central is also, obviously, many of you may know, a finance and accounting application. However, our product, even though the Asset Guardian, our product, resides on Business Central, a company can have their own, an airport can have its own finance and accounting systems. We don't need to use the one that comes inside of Business Central. We'll deploy our system as a standalone system at airports, and then integrate it back to the other business management applications that are in place at an airport.